Okay, so the next question that we have is a function transformation translation question. It says the vertex of the function f of x is given as this, and the point 3, -4 lies on the parabola as well. So we have 2 points on this parabola, and if g of x is equal to 4 times f of x minus 2, what is the value of g of 0 minus f of 0? So we want to find both the value, the equation of the function f of x, and also the g of x. And to do that, you need to do like use the vertex, do ax squared plus bx plus c to find the a, to find b, to find c, and then use 4 times f of x minus 2 to find g of x. That's going to take a lot of time. What we're going to do instead, we have 2 points on this parabola, right? So let's just see these 2 points in the table, 9, -13, and we can do 3 minus 4. These are the 2 points in the parabola. I'm going to add a quadratic regression. There we go. So this is the points, but the question says this 9, -13 is the vertex of the function. So I want this 9, -13 to be the vertex. This is the vertex. If this is the vertex of the function, this is the next point. So the function would look like this, going like upward. Because if this is a vertex, it can't go downward, then it wouldn't be the point here on the parabola. So this is an upward function. This is gonna should be like this. Now you might say, why the DESMOS has graphed it this way? Because we only know 2 points, so we can have like multiple ways of graphing the parabola here. But what we're gonna do now, since we know that this is gonna be the vertex and parabola is gonna look like this, the distance of this vertex, this point from the vertex, is gonna be the same as distance of this point from this vertex, because we know the parabola is symmetric, you know. So here, what is going to be the other second point on the other side of the parabola? It's gonna have the same y values. It's gonna have still the -4 y value, but the x coordinate is gonna be 3. From 3 to 9 is 6 units. So at 6 to 9, we're gonna have like the same distance. It's gonna be 15. So the next point on the parabola is going to be x15 and -4 as the second coordinate. So now, as you see, these 2 points, like the parabola, this is the vertex of the parabola. As you see, the bottom point of the parabola is 9, -13. That's the vertex, and these are 2 points that is symmetric based on the parabola's symmetrical line, and they're just in the 2 opposite sides of the parabola. So we graph the parabola now. This is f of x. Now I can click on this, put the f of x down right here. This is a, this is b, this is c. You wanted to find these on the paper. So and these are like 0.25, 4.5, 7.25. Now what we're gonna do, I'm gonna define this as f of x. Now I can define this g of x. G of x equals 4 times f of x minus 2. And there we go. We are looking for f of x and we are looking for g of x. What we're looking for is g of 0 minus f of 0. So let's do that. G of 0 minus f of 0. The 61.75, that's going to be the answer for this question. So 61.75 is the answer to this question. That's how you do this question in the fastest way, in the smartest way, the most efficient way, using DESMOS. And this is the most accurate way that you can do this. You might do some errors, calculation mistakes if you were going to do it on the paper, and you might waste a lot of time too. So that's how you do this question, a hard question.